Hey guys, today we're going to work on being able to simplify square roots and cube roots that are not perfect. So if you remember from a little bit earlier this unit, we were working on what happens when we have the square root of 25. And it turned out that that actually was a rational number when we took the square root of it, because 25 can create a square with an area of 25. The side lengths would be 5 by 5, and that would give us 25 squares in the middle. There'd be 5 going that way, and then 5 going this way, which gives us a total of 25 squares. So because the number 25 can create a square and represent the area of that square, when we take the square root of it, we get 25. Or excuse me, we get 5. Same thing if we were to take the cube root. That's the symbol, the radical symbol for cube root. Okay, the 3 happens to be the index of the root. The symbol is the radical. And the number we are taking the cube root of is called our radicand. So 27 would be our radicand. All right, so if we don't know how to find the cube root of 27, we can do something which is called the prime factorization. We can find out what numbers go into 27. 3 times 9 is 27. 3 is prime. 9 can be broken down into 3 times 3. Those are both prime. So we end up with 3 groups of 3 all multiplied together to get to 27. That's what we're looking for. It's 3 groups of the same number. So the cube root of 27 is 3. It is also a rational number. All right, so what happens if we need to simplify the square root or the cube root? Okay, I'm just going to go ahead and extend this page just a little bit. All right, so what happens if we have, let's say, the square root of, let's do the square root of 720. So my quick question is, can you think of any factors of 720? I'm pretty sure that we can take 720 and split it up into the square root of 72 times 10. Is that right? Okay, so I'm still just doing my factor tree. Okay, the square root of 10 can be simplified to be the square root of 2 times 5. Those are both prime numbers, so we're good. 72 can be broken down into 9 times 8. Okay. Neither one of those are prime numbers, so let's go ahead and keep breaking them down. I'm pretty sure that we could take 3 times 3 times 2 times 4, because the 3 times 3 gives us the 9, and the 2 times 4 gives us the 8. 3, 3, 2, and 4 are all, 3, 3, 2 are all prime, 4 is not, so I'm going to break it down into the square root of 2 times 2. So let me go ahead and try to write all of what we got out. So we've got these ones right here, these 2 right here, and those ones. So I'm going to go ahead and put them in order. So the square root of 720 can be broken down into the square root of everything. So I've got this 2 times this 2 times this 2 right here times that 2. Notice that I'm just putting them in order by choose. Okay, and so times 3 times 3 times 5. Okay, so let's look at that. I'm pretty sure that 2 times 2 is really 4. And so this 2 times 2 became that 4. This 2 times 2 can become that 4. And then 3 times 3 is actually 9. Why do I care about that? I care about that because 4 and 9 are perfect squares. So when I take the square root of this 4 right here, I get 2. When I take the square root of that 4 right there, I get another 2. When I take the square root of that 9, I get a 3. I can't take the square root of 5 because it's an imperfect square, so I can just leave it underneath that radical symbol and call it the square root of 5. Now 2 times 2 is 4, and 4 times 3 is 12. So I can simplify the square root of 720 to be 12 times the square root of 5. My whole goal, prime factorization, was to get down to only prime numbers. Once I got that, okay, I got that right here. Once I got that, then I was able to break it down into perfect squares. So the square root of 4, the square root of 4, and the square root of 9. And I could not break down the square root of 5 because it was an imperfect square. So I went ahead and figured out what the square root of 4 times the square root of 4 times the square root of 9 was, which was 12. And that is how I got 12 times the square root of 5. You can also do this with cube roots. Okay? So let's say I want to find, this could be kind of ugly, but let's say I want to find the cube root of 100. Don't be tricked into believing that the cube root of 100 is 10 just because you know that the square root of 100 is 10. So I'm going to break it down into some prime factorization. Okay, cube root of 10 times 10. Ew. This was not a wise choice to do. Why not? Why did this not work out? I don't know. Let's keep going though. Can I break apart 10 into 2 times 5 and 2 times 5? So then I can find the cube root of those. And I ask real quick. 2 times 2 is 4, but that's not a perfect cube. 5 times 5 is 25, but that's also not a perfect cube, so I'm kind of stuck right there. Simplifying the cube root of 100 is not very easy. Alright, what if we were to take the cube root of, I don't know, 90? No. Let's do the cube root of 80. Notice that I'm just kind of thinking out loud because I'm trying to give us a good example. Alright, if I wanted to find the cube root of 80, I could break that apart into 8 times 10, right? Because 8 times 10 is 80. Now, I believe that the cube root of 8 is actually 2. Because 2 times 2 is 4, and 4 times 2 is 8. So I can simplify the cube root of 80 to be 2 times the cube root of 10. Could I not? I could even go one step farther, and I'm pretty sure I could say that this is 2 times 5. So 2 times... Ooh, actually, let's slow down. I'm going to back up just one step. Okay, I'm not going to find the cube root of 8. I'm going to break it apart into 2 times 4, and 2 times 5, and 2 times 2. Now I'm going to rewrite it. Okay, I'm going to rewrite it as the cube root of 2 times 2 times 2 times 2 times 5, because 1, 2, 3, 4. Okay, so that is... This right here is our 8. Hey, that's what we already had. So the cube root of 8 times 2 times 5. Okay, there's my perfect cube. So that is 2 times the square root. No, or the cube root. I'm just going to leave it as 10. I think that I did a really good job when I did that before, because I like the square root of, or the cube root of 10. Okay, so the whole goal is to break them apart. Prime factorization is what allows us to find the cube roots and the square roots of numbers. To simplify them, you're breaking them down to write them in a simpler form, such as 2 times the cube root of 10 is a bit simpler than actually needing to find the cube root of 80. Okay? I hope this helps you. Have a wonderful day.